day, students. Today we shall learn about a new technique in objects called holography. The term is coined from two words, holo meaning whole and graphy meaning to write. So this term holography means to write as a whole. Okay. Now the picture shown is the setup for taking a holographic image, and here we make use of a laser light, a lot of optical components like lenses, mirrors, and photographic plates. Okay, so let us learn what do you mean by this technique. Now, Denis Gabor was the first person to think of the idea of holography, and it was Lathe and Upatniks who developed the first practical holograms. Now, holography is a technique of photographing three-dimensional images of objects and reconstructing the images. Okay, so this technique consists of two processes: photographing three-dimensional images of objects and reconstructing the images. Okay. Now, what is the hologram? The hologram is the recording of interference pattern. It is the recording of an interference pattern. It is formed between two beams of coherent light coming from the same source. Okay. Now, let us look into detail how holography works. It involves two processes: the recording of a hologram and reconstruction of the image. Now, in recording of a hologram, we have coherent light falling upon a mirror and an object. Okay, so the incident light is coherent. Usually laser light sources are used, and light is made to fall upon a mirror and an object. Thus, light gets reflected from the mirror and it will fall onto a photographic plate or a hologram, a recording medium. Okay. Light is also reflected from the object. Okay. So here the single beam is divided into two: the reference beam coming from the mirror and the object beam coming from the object. These two beams, they superimpose upon each other and produce an interference pattern on the recording medium. They produce an interference pattern here on the hologram. Hence, that pattern gets recorded on it. Now, here we should take notice that each point from the object is recorded across the whole photographic medium or hologram. Okay, so each point from the object is recorded to each point on the hologram. So there will be one to many correspondence. Many regions on the hologram can contain the data about a single point on the object. Now, let us use this figure to describe the process of recording of a hologram. The laser light is split into the reference beam and object beam. Okay, the reference beam is coming from the mirror and the object beam is coming from the object. The reference beam and scattered object beam are allowed to superimpose on a recording medium. Here it is the photographic plate or hologram. The interference pattern is formed, and it is a complex pattern of lines and swirls. Okay, so the patterns that we have seen till now, there were alternate bright and dark lines They were repetitive lines, they had a definite pattern. But here it need not be the case because light is scattered from the object. Okay, so since a scattered beam is superimposing upon a reference beam, the pattern can be complex. It can have lots of lines and swirls. Now, the developed negative of the recording medium is the hologram, the photographic plate after it is developed. Okay, so that negative is called the hologram. The hologram carries a record of both the intensity and phase of each point of the object. Now here again we have a diagram showing the recording of a hologram. So light from a laser source, light from a laser source is made to fall on a mirror, and that mirror can direct the laser light to any direction that we need. So it is a directional mirror. Depending upon its angle, we can direct the ray. And here it is directed towards a beam splitter. So in the beam splitter, it gets split into two. One of the rays is the reference beam, and it is expanded by making use of a diverging lens. And this expanded reference beam falls on the photographic plate. Now the other beam that is split, it is expanded again using a diverging lens and made to fall on an object. So this light gets scattered from the object, and the scattered object beam falls on the photographic plate. Now, the next process in holography is reconstruction of the image. So we have constructed a hologram. How do we reconstruct the image from it? For that, we take the hologram and laser light is shown, or it is passed through this hologram. Take care to use the exact laser light that was used to construct the hologram. Okay, so this light should be exactly similar to the one that was used to construct the hologram. Now, when this light is passed through it, this hologram is acting like a grating. Okay, so it will bend light in both directions. Okay, so most of the light will pass through, and we get one of the diffracted beams on this side where you can see the real image of the object, and on the other side you get another diffracted beam. Okay, so at that position also you will be able to see an image of the object, but that you can see it through your eyes. If you look from that point, you can see an image there. Okay, but that is actually a virtual image. Okay, so this real image, it can be photographed. You can place a screen there and take a picture of that image. But for the virtual image, you cannot take a picture. Again, this figure shows the reconstruction of the image. Laser light is illuminated onto the hologram. Okay. Here the term is used reconstruction beam. Okay. The laser light used to reconstruct the image is called the reconstruction beam, and it is illuminated onto the hologram. Fringe pattern in the hologram act as a diffraction grating. Okay. So diffraction grating, it diffracts light. We will look into it in the following chapters, and it produces a diffraction uh, beam. Okay, so it produces two beams on either side of the hologram. This is one of the beam and this is the other beam. The diffracted rays form two images. The virtual image is formed at the same location formerly occupied by the object when it was photographed. Okay, so this virtual image is formed at the same point where the object was placed earlier during the construction of the hologram. Okay, and the virtual image is used for viewing the 3D effect. If you look into this virtual image, you can move across this virtual image, you can move around it, and you can see the three-dimensional figure. The real image is formed in front of the hologram. Okay, and it is used to take photographs of the image. Now, since light is passing through this hologram, it is called a transmission hologram. Okay, now let us see what is the difference between taking a photograph and taking a hologram. Okay, well, what is photography? It is the recording of the intensity of light reflected from an object. Okay, whereas holography is the recording of an interference pattern. It is the recording of an interference pattern which is formed between two beams of coherent light coming from the same source. Okay. So in photographs, only the amplitude of the light, or in other terms, the intensity of the light is stored. Whereas in holography, the amplitude and phase of light is stored because of interference. In photography, two-dimensional data of the object is stored in the photograph, whereas in holography, the three-dimensional data of the object is stored in a hologram. In a photograph, we have one-to-one correspondence between the object and image. Okay. Whereas in a hologram, we have one-to-many correspondence between the object and image. Hence, a small bit of photograph will not be able to reconstruct the whole image, whereas a small bit of hologram can reconstruct the whole image. That is, if the photograph gets torn or shredded into pieces, I can't take a small bit of the photograph to again recreate the whole picture. Whereas if the hologram gets broken into small pieces, I can take a single piece and again reconstruct the whole image. Last but not the least, the information carrying capacity in a photograph is comparatively low, whereas the information carrying capacity in a hologram is very much high. So this was a comparison between photography and holography. With that, we come to the end of today's session. Thank you.